Hey guys, welcome to PCMisNoRatta and you're watching this video on rational numbers by Sonal Gupta. In this module, we are going to learn about the basic concept of what is a rational number and which are the numbers which can be categorized under rational numbers. So let's start with the definition of a rational number. I would first give you a random definition in my own terms. So basically I would say a rational number, you will get the answer from the name itself. In the most simplest terms, we will say a rational number is a number that can be represented as the ratio of two integers. So I have two integers, say p and q, and if I can express any number in this form, we would say that is a rational number. Like we can check it out for say a number 1. So we can write number 1 as 1 upon 1 minus 5 upon minus 5. You can take it to 100, thousands and any number. So 100 upon 100 and so on. So 1 is a rational number. 1 means all integers, you can express them as rational numbers. Like we can also check for a negative integer. So I have minus 6. So I can write it as minus 6 upon 1 or 12 upon minus 2 or 24 upon minus 4. Every time you're going to get is minus 6. Therefore, positive or a negative integer, it can be expressed as the ratio of two integers. Therefore, we would say that integers, they fall under the category of rational numbers. So I would say integers, they belong to rational numbers. We use the alphabet Q, capital Q, to denote the rational numbers. Now we can check for some decimal numbers. So I take here 4.25. You have already learned in your junior classes that a decimal number, it can be expressed as 425 upon 100, right? Just remove the two decimal places and you add two zeros here. If you multiply or double it, it would become 850 upon 200. Or if you simplify it to the smallest terms, you will get 17 by 4. But every time 4.25 can be expressed as ratio of many two integers. But mind it here, the decimal which I have opted is actually a terminating decimal. So this means that a terminating decimal number also belongs to rational numbers. And now we check for a non-terminating but a repeating or a recurring decimal. Like I have the number 0.333 and so on. This is going to repeat infinitely, so I can write 0.3 bars. Actually you have dots here. So 0.3 bar, this is a non-terminating but a repeating decimal, and this can be written as 1 by 3, right? Similarly, I have a number 0.81 bar, right? I've again taken a non-terminating recurring decimal. This can also be expressed as 9 by 11. So we can say that recurring decimals are also rational numbers. Therefore, based on all our discussion till now, we can say that all integers, terminating decimals and non-terminating but recurring decimals are rational numbers. And hence we can say that the definition would be a number that can be expressed in the form p by q, where p and q are both integers and q is not equal to 0. Then that number is called a rational number. Since we know now that what is a rational number, so let's do some of questions based on rational numbers. My first question here is, a rational number is a natural number, integer, real number or whole number. So you have to pick one option. See, if you look at natural number, it's only 1 onwards. So that means the negative integers are not a part of it. So this option is not correct. If we say integers, yes, that is correct. But then rational numbers are not just integers. Even the decimal numbers are rational numbers. So whole number would also not make the correct choice. So real numbers, because they include the integers and the decimal numbers, whether terminating or non-terminating, therefore real number will be the correct option. So a rational number is a real number. And now we would have a look at another very important question based on rational numbers. It says that show that 0.23535 so on up to infinity can be expressed in the form P upon Q, where P and Q are integers. So we see here that the question demands that we express this number in the form P by Q. So for that, we assume that let this x be equal to 0.23535 and so on. If we multiply, we can give this number as 1, equation number 1, and if we multiply this by 100 on both the sides, so this would become 100x is equal to, if you multiply this right hand side by 100, it becomes 23.5353 and so on. Now 23.535, if you check in the rough work, see 23 so it can be written as 23.3 plus 0.2353. So when you add up, you would get the same number. So 23.3 plus 0.235 would give you 23.5353 and so on. And see, this number 0.2353 so on is actually x. So that means we can write that 100x is equal to 23.3 plus x. And now if I take this x on the other side, I would get 99x is equal to 23.3, or x is equal to, that's cross multiplication, I would take 99 down here and it becomes 23.3. So I can actually remove the decimal sign here and put a 0 down. So that would actually make 10 into 99. So yes, the given number x can be expressed as 233 upon 990, right? That is the ratio of two integers. So we have written 0.23535 in the form P by Q, where P and Q are integers and Q is also not equal to 0. So we have learnt about rational numbers and some of the questions based on rational numbers. In our next video, we shall continue with irrational numbers and we'll discuss the concept and some of the questions. Thank you for watching. If this video was helpful, don't forget to subscribe and like and share with your friends. Thank you.